Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Yin Yang Doubler Uniqueness by Oddly Even. And here are the rules. We have normal Sudoku rules applied, which means put the digits 1 through 9 once each into every row, column, and box. We have yin-yang doublers, where we need to shade some cells in the grid such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. And no 2x2 area may be all shaded or all unshaded. So as an example, this is an example of a valid yin-yang shading. What is orthogonally connected? An orthogonally connected region is where basically you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So for example, to get from here to here, you can go this edge to here to here to here, and that would all be within the region. Same with this. To go from here to here, you can go from these edges along this region, all while staying within the region there. So that's why this is an example of a valid yin-yang shading. What is an invalid shading would be something like this, right? Because now these cells can no longer go to any of the other cells in the region by just going through edges. They would have to go through a corner here, or they would have to go through an edge and exiting the region. Also, this can't work because this can't get to any other cells in that region just by going through edges. It has to go while staying within the region. They either have to go through a corner this way or go through an edge and exiting the region, which is not allowed. Another example of an invalid shading is be something like this, because this 2x2 area is now all fully shaded, and that's not allowed. So those are examples of valid and invalid yin-yang shadings. Now, a shaded cell has a value equal to twice its digit. An unshaded cell has a value equal to twice its digits minus 1. So in other words, double the digit first and then subtract 1. So no digit is actually equal to its, well, unless you calculate it out. But no digit is actually equal to its actual digit, or no cell is actually equal to its actual digit. You have to double it all the time, and for a shaded cell, it's basically that value. For unshaded cell, you need to subtract 1 from that value. So that's interesting. So for example, if we had, say, a 6, say we had a 6 here, that would be equal to 2 times 6, which would be 12. Well, if we say we had a 6 here, that would be equal to 2 times 6, which is 12, minus 1, which would be 11 then. So that's interesting. Okay. We have uniqueness, where on each of the constraints below, values do not repeat anywhere in the puzzle. For example, if there is a shaded 5, which is value 10 on a Renban, so say there was a 5 here that were shaded, which has value of 10, shaded 5 can't appear anywhere else on a Renban. You could not have another shaded 5 here. But an unshaded 5 could, because it has a value of 9. Right? So that value would be 5 times 5, or 5 times 2, minus 1, which would be 9. So values do not repeat anywhere in the puzzle. Okay. Values on a purple line form a set of consecutive numbers with no repeat. So if this were value, essentially, this was a shaded, unshaded 5, that would be 9 in value. Well, that's actually going to be problematic. That's interesting. Say we had an unshaded 5 instead of being there. Say the unshaded 5 was here. That would be a value of 9, which is 5 times 2 minus 1, which is 9. And we could have a value of 4 here, or sorry, a shaded 4 here, which would have a value of 2 times 4, which would be 8. And then the values form a set of consecutive numbers, which would be 8 and 9. Um, any other combination actually would not work. So that's interesting in that aspect. So those are examples of that's an example of how Renban works. We have arrows where values along an arrow sum to the value in that arrow's circle. So again, remember there's uniqueness of values across all the constraints. I don't know if that includes like arrows versus circles. I think that might not. That might be different. I don't know though. But say we had I don't know, 3 here. That would be value of 6. Um, plus a 5 shaded here. That would be value of. Oh, wait, no. Unshaded is minus 1. So that's actually not going to work either. That's interesting too. Um, hmm. Let's say this was unshaded. Then if this is unshaded, that's shaded. We have a value of 5 minus 1, right? 3 times 2 minus 1 is 5. Sorry, 5. I don't know where I got 5 minus 1. And then we have value of 10. So 3 times 2 minus 1 is 5. 5 times 2 is 10. So that would be 15. And therefore you could have 8 here. Oops. Which would be, so this, since this is unshaded, it would be value of 8 times 2 minus 1, which is 15. So the values here must sum up to the value that's in the circle. And that's an example of how arrows work. We have an X where 2 cells joined by a black dot have values where 1 is, or sorry, 2 cells joined by an X have a value that sums to 10. I just completely skipped a line there. That was weird. So for example, you could have 2 and 3 here. And that would work because 2 times 2 is 4. 3 times 2 is 6. 4 plus 6 adds up to 10. So again, the 2 cells in that have an X have values that sum to 10. And we have black dots, where 2 cells joined by a black dot have values where 1 is double the other. So, ooh. That's interesting. So then you could have something like 1 and 2 here. So 1 times 2 is 2. 2 times 2 is 4. And 2 and 4 are in a 1 to 2 ratio here. You could have actually had, if there's a 2 here, this could have been 1 or 4, but we already used a 4 in the box, so I didn't want to do that. But that's another example of how those black dots could work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, we know for certain every 2-line Renban has to be 1 shaded and 1 unshaded. It's guaranteed. And I think for every black dot, you're never going to have one, since everything is doubled. Oh, that's not true. You could have, say, something like, there you could have 5 unshaded to 9, right? Hmm. Right, so that's going to be a little problematic. Okay, so what are the values? For 1, we have 1, 2, 3, 4. Okay, it's just going to be 1 through 9 in each of these. For the unshaded, we have a certain amount, and for the shaded, we have a certain amount. For 1, the value is 1 times 2 minus 1, so that would be 1. For 2, it's 2 times 4. Sorry, 2 times 2, which is 4 minus 1, which is 3. I think it's, so it's 1, 3, 5, 7, 9, 11, 13, 15, and 17. And then we have 2 through 18 for all the shaded cells. 14, 16, and 18. So we have all the digits from 1 through 18. That's interesting. How many digits do we have on renbands? We have 1, 2, 3, 4, 5, 6, 7, or 5 times 2, which is 10. 1, 2, 3, 4, 5, 6, 7. So 17 digits on renbands. We know 3 of these are going to have to be different shades than the others, but we don't know what shading it is. So the values we have are 1 through 18. For the 2, so for in a 2, for the black Kropke dots, anything in a 1 to 2 ratio, we have 1 through 9 then. Okay. Arrows. What's the minimum for 2 digits? It could be, it's 1 and 3, right? But that would add up to, well, you could have 2 doubled. How about adding up to 10? So to add up to 10, you have to have the digits, you have to have the values 1 through 9, which are the digits 1 through 5. So these have to be 1 through 5 here. It cannot be 5 by itself. So okay, what are the possible combinations? One unshaded with 5 unshaded. One shaded with 4 shaded. Oh, that's interesting. So we know the shadings on both have to be the same. So to add up to 10, it's either 1, 9, or 3, 7, or 2, 8, or 4, 6. All of which are the same shading, and obviously you have... So if the 2x2 box... So these are the same shades. These are the same shades. In a 2x2 box, you cannot have repeats. Or, sorry, you can't have the same shading all throughout. So one of these is one shading, the other one is a different shading. So we know this is also a change in shading. You can't have this be one shading and this a different shading, so that because then these would be the opposite shadings, and that would be a deadly pattern for shading, for yin yang shading. You can't have a diagonal that's one shading and then the other diagonal be the opposite shading. And the reason why is if you try to orthogonally connect one set, that will necessarily break the other set into two separate regions, which is not allowed. So therefore we know all of this is one shading, all of this is one shading. Okay. That's interesting. So 1 would be unshaded with 5. One could also be shaded with 4 shaded. 2 and 4 could be unshaded there. So you're guaranteed 1 has to be here. Because if you don't have 1, the problem is 1, that means you don't also have 5 available, because 5 can only go with 1 unshaded. That would mean you have 2, 3, and 4 only, which can add up to 10. But obviously the 1 and 5 both can't be there in that case. So 1 is definitely one of these digits. Can you not have 2? I don't think so, right? So say you don't have 2. You have 1 and 5 can get together, but 3 and 4 cannot. So you have to have 1 and 2 here, guaranteed, which means the rest of the box is 3 through 9. Can be 3 through 9. What else can you have? So 1 can be with 5 or 4. 2 can be with 4 or 3. So you could say have 4 and 6 and 1 and 9. That is possible. So that would be shaded 2 and 3 and unshaded 1 and 5. Or you could have shaded, so that would be 2 and 8. Can you have 2 and 8? The answer is no. If you have 2 and 8, the problem is 7 is no longer available because we are using 8 to add up to 10. So that would be shaded 1 and shaded 4. But then we wouldn't have a 4 available. So you couldn't have an unshaded 4 and an unshaded 2. So the only other combination would be 4 and 6. But the problem with that is then you'd have all of those be shaded, which is not allowed. So therefore the 1 must be with the unshaded 5. And then the 2 cannot be... It has to be 2 and 4 then that are shaded. Right? Because we have unshaded 1, unshaded 5. You can't have 2 unshadeds on the other side, which you would have to add up to 10. So it has to be shaded 2 and then shaded 3. So we know that this is essentially a 1, 5, 2, 3 quadruplet, which eliminates 2, 3 with 3 and 5 in the rest of the box. So you have 1 and 9 in value. You have 4 and 6 in value. The 4 is not consecutive with any of these other values. Because the 4 has value 7 and 8, and the lowest these can be is value 11. So 4 cannot be any of these, which means this is value of a 4. Okay. So what values do we have on the Renban so far? We have 1 out of 7 or 8. We have 6 and 7 together. And then we have 8 and 9 together. 8 and 9 has to be these two, and 6 and 7 have to be those two. That means 14 and so the one value we don't have on a red band cannot be 18, because now that we have 16 and 17 guaranteed and 12 and 13 guaranteed, 18 is the one that cannot be with another value. So we have to have a 7-8 pair here, and then that means this renban has to have 1 through 7. Because otherwise, one cannot be consecutive on a renban with another value unless it's going to be longer than 2, right? Because it would have to be 1 unshaded with 1 shaded. So this is going to have to be 7 is unshaded. And these have to be 1 through 3. Oh, well, that helps a lot. So we have 1 through 3, 1 through 3 here. They could be different shadings. They could be the same shading. We just don't know. So that's values 1 through 7. We need 8 and 9, 10, 11, and 14, 15 for the rest of the renbands. Okay. So that means we have 1 through 7. So then we have 4, 5 as a pair. So we have 6, 7 already. So 6 shaded, 7 unshaded. So the rest of the renbands have to be 4 and well, first of all, these are all 4 through 9 here. This is also 4 through 9. Interesting. Because we have a 1, 2, 3 triplet here, a 1, 2, 3 triplet here. These are also 4 through 9. No 4 here, no 4 here, and these are 4 through 9. That's interesting. You cannot have a 9 on the rest of these red bands, but it could be 4 through 8. So what are these values? That's interesting. So again, we have 1, 2, 3, 4, 5, 6 not available. You have minimum of 7 plus 9. So that means this is 8 or 9 here for these scenarios. So it can't be, it has to be 9 here. Right? Because if it's not 9, it's 16. 16 would only have 7 and 9 here, and it can't have 8 and 8 here. Because you can't have repeats on this. So this must be a 9. So that's a 9, which eliminates 9 here. It also eliminates 9 on the arrow. We couldn't even have that. To add up to 9 again, we have 17. It's 17 or 18. So I think, what are the possible combinations? 17 could be 7 and 10. 18 could be 7 and 11. So we're guaranteed this is no 7, 8, and 9 here. This is no 7, 8, and 9. What are we guaranteed? Okay, so where is 9 then in box 5? It has to be here. So that's 9, which eliminates 9 here. This can't be 9, and none of these are 9. One of these has to be 9 and cannot be the Renban, so it must be there. So if this were 8 and 9, 8 has to be there, so this can't be 8 here. So we don't know if this is 17 or 18. If it's 18, so if it's 17, the values are 7 and 10 and 8 and 9, which would be a 4-5 pair for both. If the value is 18, you cannot have 9 and 9. It would have to be 7 and 11 and 8 and 10. So we're guaranteed a 4 no matter what in each of these arrows. So both 4s are here, which means you cannot have 4 on the rest of the arrows, at least. This also cannot be 4 here. So this is going to be 5 or 6 here. This is going to be 5 or 6 here, which means... Okay, wait, no. So this cannot be 5 and 6. So the possible Renbands we have left are 4 and 5, 5 and 6, and 7 and 8. Because we have 6, 7 here, and we have 8 and 9 here. So this cannot be 5 and 6, which means it's a 7, 8 pair. So that eliminates 7, 8 as a pair in any of the rest. So we know 5 has to be here, and 5 has to be here. And it's either 4 and 5 here, and 5 and 6 here, or this is 5 and 6, and that's 4 and 5. Either way, 5 cannot be here or here, which means where can 5 be? 5 has to be here. So that's 5, which is unshaded, which must be with 1 unshaded. That means both of these are all 3 of these are shaded. This is shaded, this is unshaded here. So the unshaded, you subtract 1. So it must be the higher of the digits. Right? If it's 6 and 7, the 7 is 2 times 7 minus 1, which would be 13, and the 6 would be shaded. So this must be the higher of the digits. So this is 7 or 9 here, which makes that not 7 or 9 here. This is not 1s, 2 or 3. Okay. This is 7, 8 as a pair here, which eliminates 7, 8 in the rest of the column. So this is a 4, 5, 6 triplet in this box, which eliminates 4, 5, 6 in the rest of the box. So we know 4 is here, 4 is here. That means in column 5, 4 has to be one of those 3. 5 eliminates 5 from being these 2 digits. 1 eliminates 1 from being here. This is a 2, 3 pair now, which eliminates 2 and 3 in the rest of the... well, we don't need these anymore because we have the shading for that area. Remaining digits in the 2, 3 pair eliminates 2 and 3 in the rest of the row. This can't be 5. So we have, what, 4, 6, 7, 8 as possibilities there. Remaining digits in box 2 have to be 1 through 6. And again, these Renbands have to be 4, 5, 5, 6, or 7, 8. And if 4 and 5 can't be here because one of these is guaranteed to be 4, 5 and 6 can't be here because one of these has to be a 5 or 6. So that leaves that as a 7, 8 pair. That's why we know that. This is 7 or 8. So 7 or 8 would be values 13 through 16. Well, they can't double to a value that we have, so they have to be halved. So then 7 or 8 must be shaded. 7 is 14, which would be 7 doubled. 8 would be 16, which is 8 doubled. And both of those then would be 4. So we have a guaranteed 4 here. Interesting. But we don't know which one of these. We don't know if it's shaded or unshaded. 4 eliminates 4 here. Well, where is 4 in row 4? It has to be here. So this is a 4-5 pair here, which means the other one cannot be 4-5. It must be 5-6 as a pair. That eliminates 5 and 6 in the rest of the column. This can't be 6, so it's 8 and 9. 8 would be value 16. 9 doubled, 9 times 2 minus 1 is 17. So then this has to be 6 and 7 as 6 and 7 as the only digits. This 2-3 pair eliminates 2 and 3 here. It's 1. That means no 1 here. This can't be 5, 6, or 8. This can't be 6 or 7 because there's 6 or 7 in the column. 6, 7 pair in the column, I should say. Remaining digits here cannot be 9, so this is 4 or 7 here. Interesting. Well, that means 9 is guaranteed to be one of these two digits here, so this can't be 9, this can't be 9, this is now a 5-8 pair here, which eliminates 5 and 8 in the rest of the box. So that means 6 is here. 9 has to be one of these two. Remaining digits in column 3 are 1, 2, 3, and 9. Obviously, 9 cannot be here. So 7 is in a 1 to 2 ratio here, but that's not going to work because if it's 7 that's doubled, you can't double the value of 7 adding up to 13 or 14 doubled, right? So 7 has to be the doubler if that's the case. And again, that would be 14 with 7, but that would force a 4 to be here, which is not possible. So this can't be 7. This then has to be 4. That eliminates 4 in the rest of the column. This is 7, 9 as a pair, which eliminates 7 and 9 in the rest of the box. So we have 4 and 6 here. So 4 must be the one that's doubled. So this must be shaded. So it's 8, which must come from a value of 2. Or sorry, 4 doubled. 2 doubled, which is 4, essentially. So then this becomes 2. This is 3. That's 2 there. This is a 2 by 2 area that's all shaded, so this cannot be shaded here. Therefore, this is unshaded there. The unshaded cells have to orthogonally connect. 2 and 3 eliminate 2 and 3 here. It's 1 and 9 as a pair. There's no 2 and 4 here. These can't be 4 in general. 4 eliminates 4 here. Where is the 4 in this box then? It must be here. Okay. Remaining digits of column 1, we have 3, 7, and 8. Okay. Interesting. This is going to be 2 or 3 unshaded, which means 1 out of the 2 or 3 is going to have to be shaded here. Well, either way, if this is the shaded one or this is the shaded one, you can't have that deadly pattern of one diagonal being one shading and the other diagonal being the same or being the opposite shading. So that means this is going to have to be shaded here, because one of the 2 or 3 is guaranteed to be shaded or unshaded. Sorry, has to be shaded. because this unshaded one goes out here, has to orthogonally connect. That's clever, actually. So then the one here is shaded, which means the one here has to be unshaded. Interesting. Oh, these are in a 1-to-2 ratio. It's going to have to be 5, right? 5 unshaded would give us 9. And then 9 shaded would have to be... Okay, so... Ooh. So this must be 5 unshaded. And this has to be 9 shaded. So another... That means this is 7. This is 8. This can't be 5. So another thing we know about yin-yang shading is you can only swap shadings on the edge of the grid 0 times or 2 times. And the reason is if you try to swap more, how do you orthogonally connect it without breaking the other shading into 2 segments? And the answer is you cannot, right? So to connect the blues here, how do you connect the greens? You can't. Or if you try to connect the greens, how do you do that without breaking the blue apart into multiple regions? The answer is you can't. So once you have a swap in shading, you know that this has to also be swapped in shading also. So this has to be all the same here. So these are all green. That makes this blue, this blue. This is a 2x2 area that's all blue, so that cannot be blue, that's green. The green is always going to be the bigger one. For the Ren bands, right? Because it has to be the bigger one minus 1 for the unshaded cells. So then this has to be 6, this is 5, this has to be 8, which makes that 7. This is blue. So this must be 5 here, which makes that 4. So no 5 here, no 6 here, no 5 here. Huh. We don't know what the shading is here. This has to be a blue because of the 2x2 area. So does this blue. This is a diagonal that's blue, so therefore this must be the other color and be blue. We have at least 1 unshaded cell here. Could be 2. Whatever is 4 here, it has to be the opposite here. That was interesting. This cannot be value... This is value of 8. So this cannot be value of 8. It must be by the uniqueness rule set. So this must be value of 2 times 4 minus 1, 7, which makes this a 7 here. So that's 7. So this cannot be 7 here. Remaining digits in this box have to be 1, 2, 3, and 8. 8 cannot be either of these, so we have 1, 2, or 3 there. 8 is one of these guaranteed. 8 is one of these guaranteed. Where is 8 in column 6? Can't be anywhere here because of this has to be a 7, 8 here, and this is the way that the arrows work. So 8 can't be here. 8 has to be here. That means this can't be 8. One of these has to be in 9. 9 cannot be on the arrow because 9 would be at minimum 17. So 9 is one of these two digits here. It's very likely this one, but we don't know for certain that that's the case. Okay, remaining digits in row 3, we have 1, 3, 5, 6, 7, 8. 1 cannot be the sum because it's either going to be 1 or 2 in value. Can 3 be the sum here? Maybe. Um... 4 cannot be on the black Kropke dot anymore because we have both 7 in value, the unshaded and the shaded version. So this cannot be 4 here, which means this must be 4 there. Where is 4 in row 2 now? 4 cannot be here because of 4 is in the boxes. Can't be here because 4 is in the column. So 4 is there. So these have to be in a 1 to 2 ratio. 5 could be 10, so that could work. Right. What this cannot be, though, is two shaded cells here. So that removes 1 and 2 as a possibility, because both 1 and 2 would have to be shaded for that to work. Let's just continue with what these are. 4 can't be on the arrow anymore. Oh, if this is 9... These have to be different sums. I'm pretty sure the circles have to be different. 5 eliminates 5 here. This is a 1 to 2 ratio. 8 eliminates 8 here. Remaining digits of row 6 are 1, 2, 3, 6, 7. You can't have 5 here. So 5 has to be one of these two digits there. You can't have two of any two. You can't have two digits here that are 1, 2, and 3. So we're guaranteed one of these is 5 or 6 here. And it must match that one. Can 6 ever work? If 6 is the large digit here, then it would have to be 12. So one of these is guaranteed to be shaded. Because 5 or 6 has to be the large digit here. And obviously then it would have to be the shaded one. Which means one of these is shaded, one of these is unshaded. If you have 6, that would mean the value would have to be a 6 here. And that doesn't work. So this has to be a value of 5. So we have to have a 5 here. And it's shaded. Which means because that's shaded, that's 10 with 3 unshaded. So then... Right. We have 10, and 3 times 2 minus 1 is 5. So this can't be 5 here. This can't be 5. Therefore, we have a guaranteed 6 here. Interesting. Which means this can't be 6. This is 5. So no 5 here. This is 6, 7, 8 as a triplet. No 3 here. So that leaves this as a 3. Huh. This has to be not green because of the 3 by 3 that has 3 greens in it. So this is blue. We'd have a diagonal of blue. So this is blue, which means this must be blue here. So this is either going to be 2 and 12 adding up to 14, or 4 and 12 adding up to 16. So no 3, 5, or 6 here. It's 7 or 8. We have 3 blues here, so this cannot be blue. That must be green. Diagonal, that's blue, so this has to be blue here. 3 blues here, which means this can't be blue. That's green. 5 here eliminates 5 in the rest of the row. 3 here eliminates 3 there. This can't be 8. So this 6... This is value 5. What's the minimum then for these? There's no 8 here. Remaining digits in this box have to be what? 1, 2, 3, 5, 6, 7, 9. Okay. No 5 or 9 here, no 5 or 9 here. No 3s here. This can't be 9 because of the way that it adds up. Can we ever have 7 here? 7 could be value of 13. 13 plus 1 is 14. 14 plus minimum of 5 is 19. So the answer is no. So we cannot have 7 there. Okay. Hmm. Okay. You could have 6 here, though. Value of the sum is not less than... It cannot be 1 or 2 here. Can it be 5? The question, though, is... Oh, these can't be 7 here. So we're guaranteed a 7 has to be one of these two. Remaining digits of row 5. 1, 2, 3, 6 through 9. 9 anytime it's the high digit of a 1 to 2. It's 9 anytime it's next to a black crop DB dot has to be the high digit. So this can't be 9 here. Which means in column 7, where is the 9? It has to be one of these 2 digits here. Interesting. Let's see. Um, 1 can't be here. If this were 1, it would have to have value of 1, which would mean that it would be with value of 2, which is also a 1. Or it would have to be value of 2, which means it would have to be with a 1-2 ratio with a value of 4. But we already have a 4 in this space here. So this cannot be 1. If it's 2 here, it could be with 3. So 2, if it were unshaded, would have value of 3. 3 would be in a 1-2 ratio with 6, which is 3 shaded. So that could work. So 2 and 3 could be together. What about 6? 6 would have to be 11, which is not going to be doubling to any value that we have, or it's 12. 12 would be with 6 also. So therefore 3 would be there either way. 7. 7, we don't have 7 doubled available, and that would have to be the high digit. So that 7 can't work. 8 doesn't work either. 8 would have to be 8 doubled would be 16, which would have to be 4 doubled, but we don't have a 4 available in the box. So we're guaranteed this must be a 3 here. So that eliminates 3 in the rest of the box. It's 3 doubled. So it's going to be 3 as a blue. Okay. So this cannot be 3 here. Where are 3 and 7 in box 9? Can't be here, can't be here, can't be here, so this must be 3, 7 as a pair. That's interesting. This is an even sum. This is going to be an odd value. So this is even, which means this must be an odd value too. So therefore this has to be a split. And because that's split, right, because this has to be an odd value, so we need 1 odd and 1 even there to add up to the even sum, because this is definitely odd. We can't have this be blue because that would force this to be green, and then we'd have the deadly pattern for yin-yang. So this must be blue here. That means this is green here. So these are all green. The blue has to orthogonally connect out. So these are blue. One of these is blue, because the 3 has to be the 6 in value. Hmm. So this is 6 in value. If it's 1 and 2, which is possible still, 6 plus 1, and that would be 1 plus 3. That would be 10. So this would be 5 in that instance. If this is 1 and 5, is that possible? 1 and 5, so that would be 1 and 9. 10 plus 3. Um, 1 and 5. Oh, this can't be 5 because of 5 in the column. 1 and 5 does not work. That would add up to 10 plus 3 is 16, which is 8 doubled. 1 and 6, though. 2 and 5. Hold up. 1 and 6 and 2 and 5, I think, both work. 1 and 6 would be 1 and 11, plus, which is 12. So then this would be 5 or 9. Or 2 and 5 here could work, right? So what we cannot have, though, is 1, 5 here. So 1, 2 works, 1, 5 1, 2 works, 1, 5 does not work. 1, 6 works, or 2, 5 works here. If this is 1, 2, I guess 6 could still be there. Well, if this is 1, 2, this has to be 5, which would make that 9. How can this be 6 is the question. You could have 2, 5 here, but if you have 2 and 5 here, so I don't think this can ever be 6 here is the point, right? If we try to not have 6, try to get 6 there, that would mean this has to be, it can't be 1, 2, and 5, obviously, because then you would have 3 digits, 4 digits requiring 4 through 6 here. Then it would have to be 2, 5 here, which would force that to be 9, but the 5 would have to be here because it can't be here. So 6 can never be there is the point, right? One of these is going to have to be 5 or 6. One of these has to be 5 or 6. That's interesting. So whatever digit is here must be with that digit. Okay. So this is either 1, 2, 1, 6, or 2, 5, which means we're guaranteed a 1, 2, or 6 here. That eliminates 2 and 6 in the rest of the column. So this can't be 6 here. It's 7, 8 as a pair because cannot be 2 or 6. That means the rest of this column cannot have 2, 3, 4, 6, or 7, 8. So it's 1, 5, or 9 here. And 5 can't be here because of 5 in the column. So we have a 1, 9, 1, 9 pair. Also, 7 eliminates 7 here. So this is 8. No 8 here. We have a 1, 9, 1, 9 pair in row 2, which eliminates 1 and 9 in the rest of the row. So that's 2 and 6 there. Um, 5 has to be one of these 2 digits here. So the question is, does the circle count as part of the uniqueness? I think so, right? Because because otherwise it just doesn't make any sense, right? Um so if we have 9 unshaded, mm, uh these both cannot be shaded. That's clever. So if these were both shaded, the problem is we'd have a 2 by 2 area that has 3 shaded, so this must be unshaded. But then that would lead to the deadly pattern here of being unshaded here and then shaded here. So that means we have to have 1 shaded and 1 unshaded here. So it must be 2 and 3 here, which eliminates 2 and 3 in the rest of the column. That's actually kind of clever. So this is a shaded, unshaded pairing. And it has to be 2 and 3. That means this can no longer be 1 and 2 adding up to 5. Right? Because that'd be value 1, 3 plus 6 adding up to 5 doubled, which is 10. That's no longer possible. Therefore, this must be 1, 11, and 6 adding up to 9. So this is 1 and 6. This must be 9 doubled. That means this can't be 6 here. This is 8. That's 5 here. 1 and 9 cannot be here. It's 2. That means this 1, which makes that 2. 1 eliminates 1 here, so it's 6, which eliminates 6 here, so that's 1. 5 eliminates 5 here, so that's 6. This cannot be 9 doubled. So this must be 9 unshaded. So that's 17. So we cannot have, this can't be 6, it's 4. That makes this 5 there. So this is 4 unshaded, which means 4 shaded has to be there. 17 is 7 plus 10, so this must be blue. And then 8 and 9, so this must be green. So this is both shaded on this diagonal, therefore this cannot be shaded, it's unshaded. So that's the 2. This has to be shaded in the 3. We have a diagonal here of blue, so this must be blue here. No 2 here. 1 eliminates 1 here, so this is 9. Can't be 9 or 1, it's 5. Green has to orthogonally connect out, so it must go here and here. This blue, we have a diagonal here of greens, so, and this can't be green, so it's blue. Therefore, that's green there. The blue has to orthogonally connect out, so that's blue. 3 eliminates 3 here, so this is 2. That's 3. This can't be 2 or 3. It's 1. which is green. We have a diagonal of green here, a diagonal of green here, but this is blue, so this forces this to be green. That forces this to be blue there. So these are all 3 greens, so we need the 3 blues here for the uniqueness of value. You have 3 greens here, this can't be green, that's blue. We have 3 blues here, this can't be blue then, so that's green. Then this we don't. This is blue, so these must be blue then. That leaves that as a green because of the 2x2 area. Okay. This 2 eliminates 2 here, so that's 3, which makes that 2. This is all done. So that means all we have left is normal Sudoku rules. No 1 here. Whereas 9 in row 5, it has to be here. 9 eliminates 9 here, so that's 1, which makes this 9. No 8 here because of 8 in the column. This is the larger value, right? Yeah, it has to be 7 and 6 here. That's 7 and 6. 7 eliminates 7 here, so that's 8, which means this can't be 8, that's 7. So that's 1 and 6 adding up to the 7, or essentially 2 and 12 adding up to 14. So that's 1, that's 6, that's 2. 6 eliminates 6 here, so that's 2. 7 eliminates 7 here, so it's 3 and 7. That means this can't be 1, 3, or 7. It's 6. It can't be 1, 3, 6, or 7. It's 8. 6 eliminates 6 here. 8 can't be here because of 8 in the column. We have 1 and 3 remaining in row 1. This can't be 7 or 8 because of 7 or 8 in the row, so it's 6, which makes this 7, which makes that 8. 6 eliminates 6 here, so it's 7. That makes this 1. No 1 or 7 here, so that's 6. 6 eliminates 6 here, so it's 4 and 6. 7 eliminates 7 here, so it's 3 and 7. 3 eliminates 3 here, so it's 1. And, well, do we just double check? Let's just double check. We have values on this red band. 1, 2, 3, 4, 5, 6, and 7. We have values 8 and 9 here, 10 and 11 here, 10, 11, 12, and 13 here, 14 and 15 here, and 16 and 17 here for the Renban. For the 10s, it's fine. This is 1 and 9, 4 and 6. Arrows, we have 1, 6, and 11, adding up to 18. Here we have 2 and 12, adding up to 14. Here we have 7 and 10, adding up to 17. And 8 and 9, adding up to that same 17. And those are all unique values. Crop key dots, we have 3, 2 times 2 minus 1 is 3 and 6 in a 1 to 2 ratio. 4 and 8 in a 1 to 2 ratio. 5 and 10 in a 1 to 2 ratio. 7 and 14 in a 1 to 2 ratio. And 9 and 18 in a 1 to 2 ratio. So that should be done. And that ends with 3 in the corner. Huh, interesting. I was curious whether there was going to have to be some restriction here, but fortunately this yin-yang shading came in clutched, so that I didn't have to worry about whether we had a uniqueness across arrows versus circles thing. Yeah. Um, could we have had that situation is also what another thought, right? If this were 9 shaded, this would have to be 4 and 5 shaded. Yeah, that would have been an interesting question to ask there. But fortunately, we were forced in the situation to not have double blues there. So that essentially solved it for us without having to focus on that. Because it could have been 9 double shaded here, or 9 shaded here, with 4 and 5 shaded here, and then 4 and 6 unshaded there. That's a potential possibility. And then I don't know how this would have worked, or if it would have. But obviously, the shading forced that not to actually be the case. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.